Welcome back to this series of Power Electronics Labs. Today we will go through the Lab 4 relay circuit. The contents are 1. Introduction, 2. Circuit and principle, 3. Building prototype, 4. Testing results. Now let us start with the introduction. The purpose of this lab is to test the control circuit for a mechanical relay and a solid-state relay. The function of a relay is to use an isolated control signal to switch a power path. There are two types of relays: mechanical relay and solid-state relay. Here is a diagram of a mechanical relay. The control signal energizes a coil, as pin 11 and 12 in the diagram. The coil works as a magnetic latch to switch the power path. There are two types of power contacts. 1. Normally closed, as pin 1 and 7 in the diagram. 2. Normally open, as pin 2 and 7 in the diagram. Here is a diagram of a solid-state relay. The solid-state relay is also called optical coupler. The control signal energizes an internal LED, as pin 1 and 2 in the diagram. The optical transistor responds to the LED and switches the power path, as pin 3 and 4 in the diagram. The relays are used in slow switching applications. The time resolution is usually a few 10 milliseconds. Now let's look at the circuit of the prototype and its working principle. Here is the schematic of the prototype circuit. A common power path is used to test two relays individually. The power path consists of an external 12 VDC and two LED lights, LED 4 and LED 5. The common control circuit is used for testing. The control signal can be switched to the 5 volts, which is the output of the linear power supply built in Lab 2. The NPN transistor T1 is used to switch the control signal of the relays. Its collector pin CC can be connected to the two relays individually. To test the mechanical relay, connect the common control signal CC to the coil terminal MC. In the power path, LED 4 is connected in the normally open path, and LED 5 is connected in the normally closed path. When the coil is not energized, LED 4 will be off, and LED 5 will be on. When the coil is energized, LED 4 will be turned on, and LED 5 will be turned off. To test the solid-state relay, connect the common control signal CC to the terminal of the internal LED, SC. In the power path, LED 4 is connected to its optical transistor path. When the control signal is on, LED 4 will be turned on. When the control signal is off, LED 4 will turn off. Now let's build the prototype. The components used in this lab are the printed circuit board PCB, the linear power supply built in Lab 2, a mechanical relay, a solid-state relay, 2 LED lights, 1 diode, 1 NPN transistor, 5 surface mount resistors including 2 pieces of 1K, 2 pieces of 510 ohms, and 1 piece of 5.1K. Now let's populate the components onto the PCB step by step. First, solder the 5 surface mount resistors. Step 2, the diode and the NPN transistor. Step 3, 2 LED lights and 2 relays. Step 4, a wire is the control switch and the control signal connecting cable. After soldering on all the components, we complete building the prototype. Now let's test the prototype and show the results. Test the mechanical relay. The common control signal CC is connected to the coil terminal MC. We can see, when the control signal control is pushed down to connect to 5 volts, LED 4 turns on, LED 5 turns off. When the control signal is off, LED 4 turns off, LED 5 turns on. To test the solid-state relay, the common control signal CC is connected to the internal LED terminal SC. We can see, when the control signal control is pushed down to connect to 5 volts, LED 4 turns on. When the control signal is off, LED 4 turns off. LED 5 remains on, since it is not in the power path of the solid-state relay. Now we complete the whole lab. Thanks for watching.